Balancing chemical equations means that you're going to determine coefficients so that you're not losing any atoms. So you're going to be counting the number of atoms of each element before and after the arrow, and then adjusting to make sure you're not losing any. Let's look at this example so we can kind of see what it means. So this one is balanced, and let me show you why it's balanced. So the idea is that we want for everything before the arrow, the reactants, to have the same numbers and types of elements as those after the arrow, because we don't lose atoms during a chemical reaction, and atoms don't change what kind of element they are during a chemical reaction either. So sometimes people do like a little score thing where we have reactants versus products, and we could count. In the reactants, I'm going to look at each element. I have 2 elements. In the reactants, I have how many hydrogen atoms? Well, this 2, by the way, that 2 is a coefficient. That 2 multiplies through. And so 2 times 2, I have 4 hydrogen atoms before the reaction. And after the reaction, in the products, I have 2 times 2, that's 4 hydrogen atoms after. If I check oxygen, here I have 2 oxygen atoms. And after, remember this 2 multiplies through. After, I have 2 oxygen atoms. So we say that this is balanced. So your job when you balance is to add those coefficients, those numbers in front. So only the pink numbers here, when you're balancing, you're only changing those. And you're never going to change the subscripts. Never change subscripts. And the subscripts are these numbers down here. Those are determined by the type of compound, and you don't want to change those. So we're only going to add numbers in front. Okay. And then as far as hints go, there are some things that you can do to make it go more smoothly. And one thing is that if you see an element that is not in a compound, like oxygen right here is in an elemental form, save it for last. And the reason that you do that is because I can put any number I want right here, and it will not mess up one of the elements I have already balanced. Also, if an element is found in more than 2 places, and so oxygen, again, that's more than 2 places, it makes it hard to balance, so save it for last. And the reason you save it for last is on a lot of compound, or a lot of reactions, not this one, but on a lot of reactions, when you balance the other ones, that complicated one will be done for you. We'll balance this one here in a little bit. Let's start with something simple. And so I don't, kind of looking at my rules, I look for an element that both of these, copper and oxygen, are elemental forms, so it doesn't really matter which one I would save for last. Although I will say there's an advantage to saving the copper because I can, it doesn't have the 2 basically. But anyway, it doesn't really matter. It looks like really fast that copper is already balanced. So let's balance oxygen. And what I mean is I have 2 oxygens here. And so I look over here, I need to have 2. And again, I can't put 2 there. That's changing what the compound is. Only change coefficients when you balance. So I'll put a 2 in front. And then I see that this 2 just affected copper. So let's go and check our copper. I have 2 coppers here. And so I need to get 2 of my reactants. So I'll add a 2 there. And so that's balanced. This one is a little trickier. I do see that aluminum and silver are elemental, and so I would save those for last. I would do sulfur first. Let's see where it goes though. So I'm going to start with sulfur. On my product side, I see I have 3 sulfurs right here. And on my reactant side, I only see 1. So I'm going to add a 3 in front there. And that just affected my silver. So I will do silver next. How many silvers do you see there? I see 3 times 2, that's 6. So I need to add a 6 here. And then I haven't balanced aluminum yet, so let's balance aluminum. I have 2 aluminums here. I need a 2 there. And so that is balanced. If I check each element, I would see in the reactants versus products, I'm checking aluminum, silver, and sulfur. I have 2 aluminums before, 2 aluminums after. I have 6 silvers and 6 silvers. I have, this multiplies through, so 3 sulfurs and 3 sulfurs. Okay, now this one, it looks like I would save magnesium for last because it's an element. And after that, I would say hydrogen for last because it is in an elemental form there as well. There's something else that can help you on this one, and that is that notice the element or the polyatomic ion nitrate. Notice that nitrate does not change. It's nitrate before the reaction and it's nitrate after the reaction. And that means that I can balance nitrate groups instead of balancing nitrogen and oxygen separately. The other thing I should be looking at is that I don't see nitrogen or oxygen anywhere else besides in the nitrate. A lot of times polyatomic ions remain intact, and so it makes the balancing a little easier. So I'm actually going to start with the nitrate when I do my balancing, since I said magnesium and hydrogen would be good for last. So I see 2 nitrate groups there, and so I need a 2 in front here that will multiply through and give me 2 nitrates there. And then I see, so then I would go to hydrogen next, and I would see I have 2 hydrogens here and I have 2 there. So that's balanced. And then magnesium, I have 1 and 1. So everything else is balanced. Here's the one that we were talking about a little while ago. Let's see what we can do with this one. We said because oxygen is by itself, not in a compound here, and also because it's in 3 places here in both products, I'm going to save it for last. So I'm going to do carbon first, and I have 1 carbon in my reactants and 1 of my products. It looks like carbon is balanced. Then I'm going to look at hydrogen. I have 4 hydrogen atoms in my reactant and only 2 here. So I'm going to put a 2 in front. Okay, now I've done carbon and hydrogen. Now I'm going to do oxygen. And for oxygen, I have to be careful because it is in 2 places over here. So in other words, I have 2 oxygens here, and this multiplies through. That's 2 there. So I have a total of 4 oxygens in my product. When I come over here, I need to do the same thing and make sure there aren't oxygens here, and there are not, but if there are, I would have to account for that. So I don't have any there, but here I have 2, so I need to get 4 out of this. I'll put a 2 in front there. Let's look at double replacement reactions, and we're going to predict products and balance the equations. When you have to predict products, the first thing you do is you determine the correct formulas. So when you're determining formulas, you do determine what the subscripts should be. After you get those determined, then you balance and you change the coefficients. A double replacement reaction has 2 ionic compounds, and they kind of switch positive and negative partners. Okay, let's look at this example. And I know this is double replacement because I see I have two ionic compounds, metal, polyatomic ion, metal, polyatomic ion. The first thing I would do is determine the charges on these ions. And you can use your periodic table or your maybe your polyatomic ions to do that. This one is carbonate, and it is one that I don't usually have people memorize, but carbonate has a -2 charge. So anyway, to figure out the products, what you're going to do is you're going to put the positive part of one with the negative part of the other, and it will always be the front part of one with the back part of the other. And so I'm going to put calcium with carbonate. Okay, and then I'm going to put sodium with nitrate. Okay, but when I come over and write these products, I need to make sure they're good formulas. And so to do that, I need to look at their charges. Their charges do not change during a double replacement reaction. Okay, and so what I'm doing is I'm looking at this and saying, is that a good chemical formula for calcium carbonate? And it is, because it's neutral, +2, -2, that's a good formula. When I look at sodium nitrate, +1, -1, that is a good formula already, so I'm not going to change any subscripts. Now what people sometimes will ask me, and this is a really good question, something we need to point out. So when I came over here, I did not keep this 2. Okay. And the reason I did not keep that 2 is because this 2 is there because of this charge here. It was needed to have enough positive charge. Since this was +1, I need to have 2 of those to make this neutral overall. Okay, so that 2 I did not bring over, because here I have a -1 and I don't need a 2 there. Okay, but then people want to know, why did I keep this 3? I kept that 3 because it's part of the polyatomic ion. So the polyatomic ions remain intact. I also kept the 3 for the carbonate. You're not going to lose those. So if the subscript is part of the polyatomic ion, keep it when you figure out your products. If it came from a charge, if it was there because of a charge, you don't keep it. You reconsider the charges to get your products. Okay, let me clean this up a little. Now let's go ahead and balance this. These are pretty easy to balance. It doesn't really matter where you start, but you kind of follow a chain pattern. So just spot something that's not balanced. Oh, and also on these, the polyatomic ions always remain intact, so you can balance like nitrate and carbonate and so forth. So I just see that sodium's not balanced because I have 2 in my reactants and only 1 in my product. So I'm going to put a 2 here. Remember, when you're balancing, you don't change the subscripts. We already decided we didn't need a 2 down there. So this 2 affected nitrate. I have 2 nitrates. Here I have 2 nitrates. That's good. And then I'm going to go to calcium next because I essentially just decided there was a 1 there. So 1 calcium, 1 calcium, 1 carbonate, 1 carbonate. So I kind of go in a chain. That one was pretty easy. Let's try another one. And remember to start by putting your charges up there. It'll help you as you're writing your products. So magnesium ion is in the +2 column of the periodic table. Hydroxide has a -1. Now on this compound, it's kind of different because it's non-metals, but it starts with an H, with hydrogen. And that means that it's an acid. And acids act ionic when you put them in water. So I didn't put it on here, but this is in water. These are solutions. So like in the experiment, you'll have solutions like this. So anyway, I'm going to treat this as it's ionic. And if it's ionic, this is +1. It is in the +1 column on the periodic table, and chlorine is -1. So pretend like it's ionic. Let's figure out our products. We're going to put the front part of one with the back part of the other, and they're always in the same order they were before. Whatever was in front before, which will be the metal or the positive one, will be in front, back over here. I need to look at their charges and figure out the correct subscripts. It looks like I need 2 of the chlorides to make this neutral. For my other product, I'm going to put the hydrogen ion with the hydroxide ion. And it looks like that's a good formula. Now you may notice that this compound is actually water. But for double replacement reactions, it's really handy to write it HOH and pretend like it's ionic. It makes the balancing easier. So for balancing this equation, I'm going to pretend like this is hydrogen ions and hydroxide ions, and I will balance each of those separately. If you can imagine, it would be really complicated to balance hydrogen a different way because it's in 3 different places. But anyway, so we'll balance hydrogens versus hydroxides. Where do we start? Just see something that's not balanced and we'll start there. I see chlorine is not balanced, so I'll go with chlorine first. There are 2 here, and so I need a 2 there. And that affected hydrogen. So I have 2 hydrogens. Those are not hydrogens, those are hydroxides. So 2 hydrogens, 1 hydrogen, I'll put a 2 in front. Now that 2 gave me 2 hydroxides. So I'll come over here, I have 2 hydroxides. That just affected magnesium. It has a 1 here. So 1 magnesium, 1 magnesium, and then I'm done. I'm back to chlorine.